Quadratic inequalities. I'm Anil Kumar, trying to think how to explain this topic. Well, we have made a lot of videos and the playlist has got 20 of them, in which we have solved quadratic inequalities using different methods: graphical method, algebraic method, and tables, intervals. Now here I thought, let me combine all of them and share the gist of it, the concept. So in this video, we are talking about quadratic inequalities, rather discussing the concept. So we have taken an equation, I should say inequality, which is x squared less than equal to x plus 2. Now, if you see, this is a quadratic inequality, right? It has got a quadratic function x squared and inequality sign. The idea of writing this equation in this fashion is to show you that we can actually write a quadratic function as a combination of quadratic function and a linear function. So when we are solving quadratic inequalities, we could treat them as shown here. So this is kind of a simple example which helps to communicate the concept, and that's why it is here. So what we have on a graph on the right side here is graph of x squared, right? And second graph is of the line x plus 2. So this is x plus 2 here. Now when we say x squared is less than equal to x plus 2, equal to means these points, right? The points which are common to both. Now the solution is when parabola x squared is less than equal to the line x plus 2. So that interval, that region, is part of our solution. So what we see here is, as this is our line, parabola in this interval is actually less than the line, and therefore the solution is from here to here, right? So if we drop a perpendicular from here to here, we get that from this point, which seems to be minus 1 to 2. So that seems to be part of the solution for the given inequality, right? So we say, well, all the values between minus 1 to 2 forms a solution set for the given inequality. So basically what this concept is telling you about is, whenever you have a quadratic inequality, you can treat it as a combination of a parabola and a linear function. And if you draw them on a graph, then we can easily figure out what is the solution. Well, if this was greater than, we were looking for the values which are beyond this, right? That means from minus infinity to minus 1 and from 2 to infinity. Now since this is less than equal to, the points of intersections are also included, and the interval between points of intersection, which is x values minus 1 and 2, forms the solution set. Do you get the concept? So this is one way of looking into it, and that is, when we have a quadratic function, see as a combination of quadratic and linear. Now if you draw these two functions on a graph, you can clearly see your solution. So that is one way of looking into it. Now the strategy which we normally use is basically bringing all the terms to the left side. So that is how we solve quadratic inequalities. So first step is we have to get all the terms on one side. So basically in inequalities, we try to keep 0 on the right side. So keep 0 on the right side, right? So what I'm trying to say with this, kind of like this, bring all the things to the left, which is x squared minus x minus 2 less than equal to 0. So that's what I'm trying to say. Just bring them all to the left side. Now we are comparing this quadratic equation with 0. Now, why do we do it always? Reason is that x-axis is a set of points where y is 0. Now, if we find the intercepts and we know whether the parabola is opening up or down, we can easily see, visualize or write down the result. So that is the whole idea. So in this case, at this stage, what we can do is just factor it out, right? So if we factor, we are looking for two numbers whose product is -2 and whose sum is -1. So the numbers are -2 and +1. So we can factor this as x -2 times x plus 1 less than equal to 0. So that gives us two factors. Rather, that gives us two x-intercepts for the quadratic function x squared minus x minus 2. Now these 2 points are at x equals to 2, well, the same thing, right? And x equals to -1. So we get the exact values. At times from the graph, we may not get the exact values, correct? So at these 2 points, we know we have zeros, correct? Now once we get the zeros, then what we can do is, we can adopt one method. There are a couple of ways we can go from here also. We got 2 zeros, right? So the idea is to get the zeros from here. And we get zeros as x equals to -1 and at x equals to 2, right? Now what to do with the zeros? One way is we could graph this function, right? Now we know the zeros, we can graph and figure out, correct? So if I have to graph it, so we know these are the 2 zeros approximately. Since we are only interested in the intervals, we know somewhere here will be our minimum. So let me just graph, make a parabola here, and that's kind of, don't go with the scale on this side. We haven't really calculated this value, okay? So anyway, what we see that the graph will open upwards, right? And so the portion of the graph which is between -1 and 2 is going to be below the x-axis, right? And we need what? Less than equal to 0. And therefore, from the graph, we can write down the solution, right? So from graph, we want to have x minus 2 times x plus 1, that's the graph, right? Less than equal to 0 means the negative portion. We say, well, the solution is x belongs to real numbers, where x is between -1 and 2, right? X is equal to -1 and 2. So we get our solution right there, correct? So that's another way which we say graphical method of solving quadratic inequalities. And then we talked about table of values, right? So table of values is kind of like this. What we do is we make a table with zeros on it. So we know the zeros are at, let's say zeros, right? We say zeros are at -1, this is -1, and at 2, right? So these are the zeros. And then we figure out where are the test points. So test points, we have to take, these zeros are dividing the whole plane in 3 intervals. Now these intervals are from -infinity to -1, from -1 to 2, and from 2 to +infinity. Do you see that? Now in these intervals, we take test points. Test points could be -2, here 0 is a good test point, and then 3 on this side. Now you could test your function with these points. Do you get a positive value or a negative value? That will straight away give you the answer. Or what you could do is, you could go 2 more steps, and that is write down your factors and then figure out whether the function is positive or negative, right? So in this case, our factors are x minus 2 and x plus 1. If I place this value -2 here, I get negative. If I place 0, I get negative. If I put 3 here, 3 minus 2 is positive. In the second factor, which is x plus 1, if I place -2, I get negative. With 0, I get +1, which is positive. 3, I get a positive value. And when I multiply these two, that is to say the function itself, which is x minus 2 times x plus 1. If you multiply two negatives, you get a positive, right? A negative and a positive will give you negative, and two positives will give you positive. Now what are you looking for? The inequality is less than equal to, correct? That means negative, right? Less than equal to. So we get our solution, and the solution is right there, correct? So this is the part of solution in between minus 1 and 2, right? So we again get the same solution. Do you see that? So basically we could adopt the third method, which is interval analysis, right? So this is what we call as interval method, right? So we analyze the intervals, whether the function is positive or negative. Depending on the type of inequality, you can right away pick up the solution. So in this video, it's kind of combination of all what we did. We have seen how to solve quadratic inequalities using different methods. So first is, we can look at as a combination of a quadratic function and a linear function. So it becomes a kind of system of equations from where we can solve or get the answer. The other way is, bring all the terms to the left side so you have one quadratic equation, sketch that parabola, and then figure out the answer after finding the x-intercepts. Now when you bring everything to one side, the other side becomes 0, and that's the beauty of it. The other side is 0, so you can just compare whether you are positive or negative. What do you need? If you're looking for less than, then you're looking for a solution where the function is negative, right? So that's how you can get the answer, right? So this is how we actually solve quadratic equations. I hope this video helps you to bring all the things together. And now it's all up to you. At times, one method is better than the other. So use the method which you feel the best for a given situation. I hope you appreciate it. Thank you and all the best.